Hello, my viewers. My name still remain sorry, Young with Sunday. I welcome you all to my channel on Pay You For More Academy. In my last presentation, um, I was trying to look at the characteristics of polymeric polyol, and I've done justice to that. We also look at the hydroxyl value, how this value influence foam and foam product. And it's not only that, in this presentation today, we are going to look at the molecular weight of polymeric polyol. Molecular weight of polymeric polyol. Yes, if you look at the technical data sheet, just like I said before, this one also clearly stated by the manufacturer. They may tell you that it's 2,000, 25, 35, 5,000 up to 6,000. Just like I said, the formation of polymeric polyol all depend on the degree of polymerization. So the molecular weight is not always fixed. It is the degree of polymerization, because the molecular weight, you are looking at how short and how long the polymer chain in that polyol. That is what the simple mean, the molecular weight. That is what is measured. Okay. So when looking at molecular weight, you look at in terms of the polymer chain length. Polymer chain length. Okay. You can also look at in terms of reaction speed. You also look at in terms of uh, viscosity, then etc, etc. But for the purpose of clarification, we shall be looking at in terms of reaction speed and polymer chain length. Just like I said, the molecular weight is telling us that how long is your polymer chain and how short is your polymer chain in that your polyol you are going to use. So increase in the molecular weight increases the polymer chain. Decreases in molecular weight is telling you that the polymer chain is a bit shorter. So they are looking at the average number of atom in that chain that will now result in this number. So it's all depend on the degree of polymerization. It is not same in all polyol. Now, how does this influence our foaming reaction? That is to say, you will notice that for those in industry, you want to produce a 22 density, for example, 22 density, and you use a different polyol, the formulation parameters is the same, the temperature is the same, and you discover that the reaction occurs so fast. I hope some of us experience it. Your reaction occurs so fast. So there is something that that reaction is telling you, that there's what we call viscosity buildup. So those with higher molecular weight, the viscosity would increase. So as the viscosity increases, the rising time will also be affected in one reason or the other. You know, most of us, we also had a non-reactive filler like calcium carbonate into it. And one of the things we should know that when you are increasing your filler load in your foaming formulation, the reaction time will also do what? Take a longer time. Okay, it will affect the reaction time. So that is to say, you have to ensure that your formulation is well balanced. And I did say that for you to increase filler load in your foaming process, that is not the question. The question is that you have to select the good polyol and balance this your filler blending excellently so that you will not have problem of split, crack, and at the end of the day, your mechanical property will meet up with the national standard of that country, because every country has their own national standard. National standard is set consensuously, not one person. Okay, and the responsibility for Nigeria is given to Standard Organization of Nigeria. Standard Organization of Nigeria do not make standard, but rather they are the how do I put it? They are the ministry that the federal government hand over the responsibility to monitor and see whether what you agree, whether you meet up with it. If you do not, I think there is a sanction for that. So in a molecular weight, when this one, I did say that I'm going to look at it in terms of the polymer chain and the reaction time. Increase in molecular weight reduces the reaction time because your foam will take place in a slower form. But as the molecular weight decreases, the foam reaction will speed up. And by so doing, it will affect the density of your foam. That's another implication. So you have to look for a way on how you will balance it with your blowing agent by reducing your water a bit. And as you are reducing your water, your index will be affected. So you have to look at it in a very balanced form. But in terms of polymer chain, those ones that are increasing, okay, as the increase in molecular weight increases the viscosity of that polyol, thereby slowing the reaction too. In this case, you are going to have a foam that gives you a strong mechanical property and a good resiliency and elasticity. Okay, but in the other one, during curing, you are going to have a formidable potential, better formidable and a curing effect, the one with a low molecular weight. Now, in terms of viscosity, I think I've used it. The viscosity build-up is going to increase it. And such polyol, I do advise people, those ones with high molecular weight, I do advise people not to chill it to some certain level. If the standard cooling system is 22 to 20 degrees Celsius of the temperature control, you can take this one up to 23 to 25. There's nothing going to be wrong with your foam, because one of the factors, many people do not know that when your temperature is too chill, you are going to experience problems in your foaming process. You consume much additive, okay, and when you look at the entire analysis of your foam, the call benefit will not be there. Don't chill it too much, don't increase the temperature too much. It should be in between. Okay, so that is how this molecular weight influence formulation process. For every flexible foam, polyol used for flexible foam, I think it is between 2,000 to 6,000. So it's all depend on the degree of polymerization of that polyol and the intended application. So that is how molecular weight influence foaming reaction. Continue to like my page on your notification bell so that whenever I upload a new video, you'll be notified. Subscription is free. Thank you, my viewers. Bye.